Hello, we're back here. This is a continuation of the diffusion activity that we started the last class. This is module 8. I have ice cold water here, room temperature water here, and hot water here. I have my mitten for the hot water. Hello everybody, this is Mittens. Our famous green food coloring. So I'm going to add a drop into each of these: cold water, room temperature, and hot water. So what's happening? Besides looking like the 60s again, I always like to, like, wow, man. Look what's happening. Cold water seems to be slower. Room temperature, like it was last time. And look at the hot water. The hot water is already diffused almost all the way. Okay, so what can we say about this? We've learned the concept of diffusion. Now we've taken it further. Now we can form what we call generalizations. And a generalization is the relationship between two concepts. Actually, it could be more than two, really. The higher the temperature, the faster the rate of diffusion. Temperature, one concept; rate of diffusion, the second one. The lower the temperature, the slower the rate of diffusion. Generalization. We can also infer. Infer is when you speculate, you try to explain why this is happening. Why is diffusion faster in hot water? The molecules are doing what? They're moving around faster, bumping up against the glass, they're moving around. So when you put the food coloring in, it's just diffusion is faster because the mixing occurs a lot faster. Ice cold water, molecules are moving a lot slower. So it just doesn't happen as fast. So this is how you teach science. You do hands-on activities. This is what we call a discovery demonstration because I'm doing it. And it's teaching concepts. But then we do more than just learn a definition. You develop the concept, you learn how to form generalizations, and then you infer to explain what you observed, what happened. That's how you teach science. You don't read from a textbook and answer questions at the back. That's not how you teach science. So, this is an example of diffusion. And that's what you do when you teach science. I'm going to take a cup of water and I'm going to take, let's do the room temperature water. I'm going to add more. There we go. That's a little bit too much, I guess. I can actually move these out of the way. Here's another liquid. Now you may be saying, or maybe a third or fourth grade student would be saying, okay, food coloring was a liquid, put it in water, it diffused, it's a liquid. So this is another liquid. So you may say, okay, this is going to diffuse also, just like the food coloring did. Oh, look at that. Does not diffuse. This is what we call a non-example. This is vegetable oil. Plain old vegetable oil bought it at the store. The vegetable oil is less dense than water. You would think water would be, water, well, why? Because oil is on top. Yeah, oil is less dense. It floats in the water, on top of the water. This is not an example. Let's have some more fun. I will drink that later. Here is an ice, it's not an ice cube, it's an ice crescent shape. What's going to happen when I put this ice in this oil and water? Water is very unique. It is less dense as a solid, which you would think as a solid it should be more dense, right? But no, it's less dense as a solid. So knowing what we know about the oil and about the water below there, let's see what happens when we drop the ice cube in there, or the ice crescent. Well, it's not sinking all the way like it should. Some of you may have predicted that the ice is going to go through the oil and float on top of the water. Unfortunately, there's a bubble. There's a bubble of oil stuck to the ice cube. And I don't know if you can see that or not. It's not allowing it to go all the way down to the bottom. Let's see if I can get some more ice. Sometimes when the ice is old, it doesn't work as well. Just a minute. Oh no. Much better. That one goes down to the water, floats on the water, but does not, of course, sink in the water, right? Why is that important? Why is it important that ice floats on water? Remember I told you that water is less dense as a solid. So in the form of ice, it's less dense than the liquid form. So ice floats on the water. In this case, the ice is more dense than the oil, so it sinks through the oil, and when it gets on top of it floats on the water because it's less dense as a solid as it is as a liquid. But why is that important in nature? In a way, life exists on this planet because of water, but because of this property too. When it gets really cold up north and the bodies of water freezes, the ponds and the lakes and all the water and the waterways that freezes solid, they don't really freeze solid. But it's important that the water freezes how? From the top down. So there's always a little bit of water left on the bottom for the fish to live, other animals that may have a way to get around and get up in their dens or whatever. I mean, like a beaver, they still hibernate in their little dens. If ice sunk to the bottom, and a pond or a lake or a river or a slow moving river, of course, if they freeze from the bottom up, all the animals that live in the water would die, and life on this planet would not exist. So that's very important that water does that. But there's just a little extra thing I threw in here. But the whole focus of this lesson was really to teach diffusion and to teach you how to form generalizations and inferences and develop that concept of diffusion going further and further. Again, teaching it that way instead of just giving you a definition. I can give you a definition. Diffusion is the evenly spreading out of molecules throughout a medium. Don't stop there. Do the examples, do the non-examples, and that's how you teach the science part, right?